Okay, so I'll get started. Today, obviously we're in a new classroom, a little bit nicer than the last classroom. This will be where the exam is and all future lectures in the class. So right here, we're at the assignment 3 lecture, and then 2 days from now on Thursday is the midterm. I wanted to go over the midterm post that I made and allow time for any questions, because what's going to happen is I'm going to show assignment 3, but I'm only going to give the UI demo and explain the basics of the assignment. And then later on, I'm going to, at home, I'm going to record the code part so I'm not so rushed getting through all the code, so I can give you more of a detailed explanation of that. So we will not be going over the code today in class, but I will be going over just the UI part for you. So I just wanted to read through the midterm post and then give any other information. The one thing I will say first, though, is that the post says that we're going up to and including lecture number 13, which is today. However, it's unlikely that anything specific to assignment 3 is going to be on the exam. Anything that I ask about Minimax or Alpha Beta or any of the search enhancements will not be specific to assignment 3. And also, there won't be any questions about the AI ethics lecture. So I guess technically it's up to and including lecture number 11 that questions will be actually specific to those lectures. So don't worry, there's none of the, will AI take over the world ethics sort of questions. It's basically just up to lecture number 11. So let's go over this. So the midterm will be taking place on Thursday, and it will be here. It's good that we actually got this room beforehand. I'm sure, has everyone taken a class in this room before? So you all knew where it was. That's good. You can actually have a table in here, which is really nice. The only thing I ask, which is not going to be actually on this slide, is that for the midterm, when you come, don't just sit at the very ends. These are really long columns, so come and sit in the middle so that the people who come after you don't have to climb over you, and if they're late, then there'll be a bunch of noise and stuff like that. So sit toward the middle if you can. So very first thing is if you're not allowed to use any electronic devices on the exam. If there are any calculations, they'll be very, very easy. Right? So it'll be 64 divided by 2 or something like that. The numbers should be pretty easy to do. So no calculators, smartphones, smartwatches. Place all your devices that you bring into the exam just in your backpack or your coat or whatever. There's lots of space for that. Or just, leave them. You don't have to bring them. There won't be any notes or formula sheets in the exam. They won't be necessary at all. All questions will be answerable via simple pencil and paper calculations, and we'll have integer answers. Someone sent me a kind of a funny question, which was like, if all the questions have integer answers, then are they all going to be calculations? No. This just means that any question that has a numerical answer will be an integer. It'll be easy to calculate. It won't be 3.141 is not going to be the answer to a question. You won't have to do that. I already talked about this a little bit, and so the midterm will cover all material in the course lecture videos and slides up to and including lecture 13, but realistically that's actually lecture 11 is what should be there. So there won't be any questions from this lecture specifically or from the previous lecture on AI ethics. The material will cover all material in assignments up to and including assignment 3. Any questions about assignment 3 will be taken from the lecture introducing assignment 3. You will not have to complete assignment 3 to answer those questions. And I guess I'll just, go ahead and say now there won't be any questions specific to assignment 3, but the algorithms that we use on assignment 3 are covered in previous lectures, okay? So there won't be any Connect 4 questions, but there will be Alpha, Beta, Minimax, those type of questions on the exam. And I know that this is a little bit of a cop-out to say that the study guide is just to look at the slides, but it really is, right? To look at the slides and just go through them, and if there's anything that you're unsure of, just do the examples until it makes sense. So if you had to do it on an assignment, so assignment 1 or assignment 2, it can appear on the exam, meaning that there could be questions there about assignment 2, the BFSs that you did, the sector map, stuff like this, all that can appear on the exam. And for the grad students, this means that questions on iterative deepening depth first search, on bidirectional search, stuff like that. So there will be one extra piece of paper for only the grad students to answer. I didn't want to print separate exams. So all the exams will contain five pages of questions, but 3,200 students just leave out the last one. You won't get any bonus questions for bonus marks for answering the grad student questions. So, but that will be very clearly printed on the exam. If I said it during a lecture video that something is a good exam question, then it could probably be on the exam. If I did an example calculation of any kind during a lecture, that's an excellent candidate for an exam question. So for example, when I did the game theory lecture and we spent like a full hour doing example matrix calculations, there will be some sort of matrix calculation on the exam. I'm not going to spend that much time on it without you having to do something like that yourself. So make sure you understood everything that's going on in that lecture, and any other lecture where I give numerical examples, that's going to be the case. On the final exam, so the second half of the course, when we talk about reinforcement learning, we'll have more numerical examples. So the final exam will be more numerical than the midterm. But any definitions, meanings of terms, algorithms, calculations, that sort of thing. And yeah, so I know that some profs say to do your exam in pen for some reason. I don't know why they would want that. Please do the exam in pencil. I'm not banning you from doing it in pen, but I do know sometimes when you do it in pen and then you have to like erase something or cross it out, it's just a big mess. So I would prefer that it was done in pencil. And you know, even though we're all adults, every year there's still like 2 or 3 students who forgot a pencil or an eraser and need to borrow one. Try and avoid that if possible. Come pretty well stocked for that, please. I will not have anything that you can borrow. So, exactly. So I won't have any extra pens or pencils for you. Please make sure you come with that. Using the bathroom during the exam is fine. All I ask is that I know everyone brings their cell phones everywhere. I bring my cell phone everywhere. So if you have to use the bathroom, just put your cell phone, let me know, and then put your cell phone on the desk so that I know you're not, you know, out on ChatGPT in the bathroom. The questions will be a mix of long answer explanation, definitions, mathematical calculations, and pseudocode algorithms. There will be no multiple choice or true or false. You will not be required to write JavaScript on the exam. So that means that if I ask you for an algorithm on the exam, it will be, I want the pseudocode for that. So pseudocode meaning that it explains the mathematics of the algorithm, but it's not any particular programming language. If you do write JavaScript, then that's okay with me. Just make sure you're not like bogged down in the details of JavaScript. I don't want to see 10 lines setting up a new array of all zeros or something like that. You can just say, you know, let array equal all zeros. It's fine. It can be almost English as long as it's pseudocode. So pseudocode is what I gave on all the slides for every algorithm. So if you have a photographic memory and you literally just write down the algorithm from the slides, that is perfectly okay with me. I always design my exams so that they should take far less than the amount of time available. Typically, the first people finishing the exams are around, I don't know, the 40-minute mark. So if you know all the answers to all the questions, the amount of writing that you have to do on the exam would probably be like 30 minutes. Any additional time that you spend is just thinking about something you're not sure about. So there will be lots of time on the exam. And this is something that I always want to make sure that none of the examples on the exam are like super tricky or a gotcha or like an edge case or something like that. They'll all be simple examples like you had in the slides, but it will cover everything comprehensively. So the midterms are comprehensive but fair. You know, no one's ever said that they're too hard. Everyone's just like, yeah, I just forgot to study that thing. right? So if you're familiar with everything, you should be absolutely fine for the exam. And like I said, there's no complex math. I'm not trying to trick you or anything like that on the exam. There will be 4 pages of questions plus 1 page of questions for 6980. And the way that I do my exams is that every page is worth 10 marks. And so the 3200 exam will be graded out of 40, and the 6980 exam will be graded out of 50, and the last page of the 6980 exam, well, the last page of the exam will be just for the 6980 students. And if you have to miss so the reason I have this at the end is because a couple of years ago, the university changed its policy so that in order to miss a midterm exam, you don't need a doctor's note, you don't need anything. You can just show up the next day and say, oh yeah, I was sick, and then you missed a midterm exam. And one year I had 17 people not show up for the midterm exam. And rescheduling all of those, and it's a nightmare because I know that questions get shared and all this kind of stuff. So I just have one policy now, which is if you miss the midterm, the grade goes on the final, right? So if the midterm is worth 25 and the final is worth however, let's say it's 30, I can't remember the exact, is it 35? Can't remember. 40. Okay, so if it's 25 and 40, then your final's worth 65. That's it. There's no weighting or anything like that. That's just how it goes. So if you can't make the midterm, you're just putting marks on the final exam. And if there's some absolute, really serious thing going on and you can't make the midterm, just come talk to me about it rather than let that be a problem for later. So the recommended study guide, like I said, literally just open up the lecture slides and go through them. There's always, whenever I give the lectures, there's more that I say in the videos than there is in the slides, of course. So if you haven't watched the lecture videos, do that first, right? Don't just go through the slides because a lot of those slides will make no sense unless I'm talking over them, right? A lot of the slides are the A-star example or the the breadth first search stuff. It's if you're just looking at the slides and you've never heard the lecture, please make sure you watch the lecture. I know that should go without saying, but you'd be surprised what some people expect. So yeah, just go through it. If you think you know it, go on to the next one. If I did an example, for example, the matrix ones, make a new matrix, put in random numbers, and then see if you can come up with something, right? Do those examples. Yeah, if you think you don't know it, study it until you understand. And it's really that simple. I'm not trying to trick you here. I know I've been in exams where profs have asked a question that you've never seen before, and it's oh well, I told you to look up that in the book. No, it's not like that. But it will be comprehensive. So if we talked about definitions and stuff, I may ask you a definition in a different way than was exactly presented on the slides, but if you know the definition, you can rephrase it in any way that you want. So the assignment 3 demo is going to take 20 minutes at most. So I've allotted a bunch of time here. If you have any questions or clarifications or anything about the exam, it never hurts to ask if something will be on the exam. The worst I can say is I'm not going to tell you. So any questions, just put your hand up. I'd be happy to answer about the exam. Nobody has any questions. So everyone's perfectly studied. You could do it now. I have them in my office if you want. No. Yeah. Well, I can't fit every definition, but any definition that I gave could be on the exam. Yeah. So I don't know. I'm not saying this is going to be on the exam, but what is the definition of an admissible heuristic? Something like that. Under what conditions is this algorithm optimal? Things like this. So anything that was said, obviously it can be rephrased. I'm not going to give you the lecture slide and just get you to fill in the blanks, but that sort of thing. Yep.
I noticed the way you index a matrix is different from the normal mathematical indexing. For example, you choose column.
Yep.
So are we to use your normal indexing during the exam or solid normal mathematical?
Well, let's say, for example, so the question just for the microphone was about the way I index the arrays. If I go column first or row first. For any question that I could ask, it really doesn't matter what order you do it in. So for example, if there's a question about a Nash equilibrium, you're going to have to find all the best responses to both players anyway. So if you find the best responses to player 1 from player 2 first, or vice versa, it doesn't really matter. The way I do it, typically, is I will go column by column first, because that's from the point of view of what I've listed as player 1. And then I swap it because that's the point of view of player 2. But the only reason that row or column would matter at all is if I ask something like, what is the best response for player 2 to all of player 1's actions? Then you would have to do it one of the ways, but not the other way. But yeah, that shouldn't matter. And again, the way I did that is because that's what makes the most like intuitive sense to me. But it doesn't matter if you find it one way or the other, as long as the answer is correct. Like I can't see the order in which you did things when I'm grading it. So that doesn't even really factor into it. I hope, does that make sense?
I was just thinking, what if you like draw out a map and then like circle it just like?
You won't have to draw your own things. I would give you something that you would circle or make a square around it or something like that. Yeah, you won't have to draw your own matrix. Yep.
What you gonna ask about the alpha beta like minimization thing that you showed, where you like collapse it into like
Yeah. So the question was about in the slides, I took the long form of alpha beta algorithm, and then over the course of a few slides, I derived the shorter form. So if I ask a question about, like for example, give me the minimax algorithm or give me the alpha beta algorithm, any of the forms that is correct, as long as it's correct, is fine. It may be shorter to memorize the shorter version of the algorithm, like it's less lines of code, but I actually find that it is easier to remember the longer form of the algorithm, if that makes any sense. Because the longer form, to me, is more intuitively correct, and it takes some logical jumps to actually get to the shorter form of the algorithm. But yeah, whichever one I ask won't, or sorry, whichever algorithm that I ask for, if I ask for any algorithm, any complete and correct version that you write down is fine. And I'm not going to say like derive the third step of this. Yeah, that would be weird. I wouldn't even know how to ask that question, sorry. Yeah. I may ask something like, here's two algorithms, are they equivalent, or why are they not equivalent? But that knowledge wouldn't involve that sort of process of decomposing things. Yeah. Sorry. Yeah.
So you said we're not going to get like any specific questions about assignment 3, but could we get specific questions about assignment 1 and 2?
Yes.
Okay.
Yeah. So one of the things that could happen is like we observed this behavior during the animated search. Explain it, or why, or what could we do to fix that, or something along those lines, right? So that is something that could come up that is specific to the behavior in the assignment itself. Yeah, and also for the grad students, question about like iterative deepening depth first search, that algorithm, or bidirectional search, or how it performed, that would be possible on the exam as well. Just trying to get everyone for their first question first. Yeah.
I was going to ask, how do we answer that kind of question? Should we write in words or like algorithm?
It will be very obvious. In fact, so I'll give you a little bit of behind the scenes prof stuff, what we talk about at the bar after the course is over. is that I would absolutely love, I think that the best way to quiz people on an exam is one, numerical calculations, and two is long answer questions, where it's like, demonstrate that you actually know this concept by explaining it to me. The problem I've found over the years with long answer questions is there's a couple of issues. One is that it is very difficult to grade them objectively. So if you're writing 2 or 3 paragraphs for an answer, and someone else writes 2 or 3 paragraphs for an answer, it's very difficult to judge those two things exactly over the course of grading 100 exams, right? Because there could be some sort of phrase that I'm looking for you to say in order to, like, this is only optimal if, but someone else explains it without saying the word optimal, but explains it in a different way. So I've come over the years, you'll find, does anyone know what Mad Libs are? Have you ever heard of Mad Libs? So it's like fill in the blanks. So now my question, oh, and the other thing about marking long answer questions, and that it just takes forever, right? I've got to sit there and read for 2 minutes for one question out of 40 questions for one exam. It's a lot, right? So I don't know how English profs do it, where they grade all these essays and stuff. Maybe they're all using AI now, I don't know. But I hand grade all the assignments. All the exams myself. I never make the TAs grade the exams because I want them to be as fair as possible. But even something like, you grade half the exams one day and then half the exams the next day, you might be in a better mood and give an extra grade here or there. Like, it's difficult, right? So my long answer stuff now, it is very obvious, and oftentimes I even start the answer for you. So yeah, it'll be extremely obvious what you have to write. And also, during the exam, so if I go to my website here, so this is what it'll look like. So I'll have a big old clock, and I'll have both of these going. And so I'll have the clock on one half of the screen, and on the other half of the screen, whenever anyone has any questions, so you raise your hand if you have a question during the exam, like, I'm not sure about this, or what did you mean by this, I will come write the answer to that in a notepad up here. So if you said, in assignment 3, what did you exactly mean by that? In question number 3A, I'll come up here and write 3A and then the clarification. And by the end of the exam, probably there'll be like a full page of notes up here just clarifying things for you. Because sometimes, like, I had a question once, and I never thought of this before, but like, phrasing on an exam is very important. Like, in my game programming class, that game programming class is all about ECS, which is Entities, Components, and Systems. And the first question on the exam was, what does ECS stand for? And one of the people in the class, English wasn't their first language, they just said, what do you mean stand for? Like, how does it stand, right? I'm like, that's interesting. That's a colloquialism, a phrase that we use that maybe someone else didn't use. So sometimes those sorts of things that I take for granted come up, and I have to clarify what I mean. Right? So I'll write those notes on the board so everybody has those answers. Yeah. It should be very clear what you have to do. Not only for your case, like, most of the things that I do on the exam are selfishly for me so that I can grade them more accurately and grade them quicker. So if I've done something like that, the secondary benefit is that it benefits you. I'm being very greedy in how I want, like, if I very specifically say, like, if I want an answer, I'll even say, here's where I want you to write the answer. So that as I'm grading exams, I know exactly where to look. So I didn't accidentally take your number from up here and interpret that as the answer, for example. Yep. Did you have another question?
Oh yeah. I was gonna say, how much like tracing should we expect? Like tracing minimax or tracing like something like that?
So there could be, for minimax or alpha beta, if I were to ask any sort of tracing, it would be, here is a tree with values on the bottom, fill in the intermediate nodes. That would be the type of question that I would ask there. Yeah.
Your office hours, right?
Yep. So I will have office
I
hours.
want to talk to you about the assignment. I've almost done. There's just one very small thing I'm having trouble figuring out.
Okay, yeah, just stop by. I'll be in there until 6, so if any of you have any questions, please stop by. But if no one, yes, but it might be, yeah, after 3:45 is fine. Yeah. Any other exam questions? I saw a hand back there. Oh, so the question was, will there be any partial marking? Of course. Like, if I ask a question and it's like, what are these 4 things? And you get 2 of them right, you'll get 2 out of 4. Or if it's like, explain this concept, and you almost completely explain it, then you'll get partial marks for that. I never leave anything blank, right? Now don't write like Dave sucks. You're not gonna like lose marks. Like it's not Jeopardy. If you answer a question incorrectly, you don't lose money, right? So it's always a good idea to write down something if you don't understand. That being said, if you don't know anything and your exam is blank, that's easy for me, right? So it doesn't hurt yourself to always just write something. I'm not gonna like laugh at you or put funny things up on the screen, after the exam. It's just always fill it out. Always try and give something. Yep. Oh, sorry, I'll get to you next.
The snow is supposed to come tomorrow. It's supposed to be pretty bad. If MUN is closed on Thursday, will we just have the exam on Tuesday?
That's a good question. I was going to post about that. I didn't want to post about it in advance, but I guess it's a good idea to post it in advance. So yeah, the exam is on Thursday. Let's say, for example, MUN closes in the morning on Thursday, and they say, we'll let you know at noon if MUN is opening up. If MUN opens at noon, the exam will go ahead at 2. Okay? So if MUN is open at all during our exam period, the exam will go ahead that day. But if MUN closes at the time of the exam, then the exam will just go to the next scheduled lecture. And I will take this lecture and I'll take the video from last year and put it in that slot. So we won't miss the slot. So if the exam is canceled due to weather, it will just be on the next class that we have in person. And so I will absolutely post about that. And, I'll let you know, hopefully by 12:30 if the exam is going ahead or not, because I'm just operating based on, just have the MunSafe app or whatever tells you that the university is closed. You had a question?
You're asking about the mathematical representation on mesh equilibrium. Are you expecting us to write some formulas or mathematical symbols?
So anything that appeared on those slides could appear there. Yeah.
Yeah, but
So-
there are no formulas for mesh equilibrium. So I'm not sure the mathematical representation for mesh equilibrium either.
So the mathematical representation for anything game theory related would be in terms of like the utility of player 1 with the subscript and S, so that one slide. So if, I'm not going to ask you for a definition of something that didn't appear on any of the slides. So if I do ask you for a definition of a Nash equilibrium, there were 2 different definitions that I gave, and those are the ones that either of those would be fine on the exam. Yep.
I have a question. Is it okay if we write in pencil? And the other one would be if we can also draw diagrams if we needed to.
So one of the first things here and in the post is to please write in pencil. I vastly prefer grading pencil to pen because you can erase things. Now that being said, let's say that the exam will be single-sided. You won't need any scrap paper, and I won't be giving any scrap paper because it's all very easily answerable on the page. But let's say you did write the whole alpha-beta algorithm, or the whole minimax algorithm, or the whole A-star algorithm, and then you realized, oh my god, all of that is wrong. It's probably best if you just put a huge X through it and write it on the back, rather than try and erase everything and have it pencil written on top of old pencil. So that's what I would recommend in that case, is just writing it on the back. Yeah. I thought I saw another hand. Okay, so it's good, pretty self-explanatory. I don't think it'll be anything too much to worry about. So, with that being said, let's get on to assignment 3. So there are some small UI elements here. I told people who came in early that because if I turn both of these on, this is just shining directly in my eyes, and I have, like, it's not too bad. I do have a bit of a light sensitivity. Like, I'll have a migraine within 5 minutes if I just have this in my eyes. So if you did want to move over, if you can't see this, just take a minute to do that now, just to move over to this side of the classroom, and I can set this up. No one? Everyone's just good? It'd be good if you move now, just so there's not a huge amount of noise while I'm explaining things. This is as big as I can make it, but I will zoom in when I'm talking about those specific UI elements. Let's see if I can maximize this. All right. So, for assignment 3, we will be applying Minimax and Alpha Beta to actually play a competitive game, which is Connect 4. So who here has either played Connect 4 or knows the rules to Connect 4 already? Few people, about half the class. So it is possibly the simplest game to explain the rules for in the world. When you play this in real life, I should have brought one, but I don't have one. It's actually played on a board that's stood up vertically. And what happens is you take these colored circle pieces and you drop them in from the top, and they go all the way to the bottom. So for example, I've done this here in this UI, where as you mouse over one of the columns, if you click, it just simulates you dropping the piece into that column, right? So there are 2 colors here. There's yellow and red. Those are the colors that are, whoever made the game decided on those colors. Yellow goes first. And so you place pieces on the board. So for example, like this. And now if I place pieces in this column, they just stack on top of each other. And with the real game, there's actually like a little slider on the bottom. And when you pull the slider, all the pieces fall out so that you can reset the game really easily. Over here, there's a restart game button that you can push. So you keep placing pieces on the board until the name of the game is Connect 4, until one of the players gets 4 in a row of their color. And so I didn't play very well just then, obviously, but that 4 in a row can be horizontal, vertical, diagonal, or the other diagonal. And so anyway, let me just play another one here. So for example, I'll put this here and this here, this, oh, Jesus. I didn't mean to do that. But what I was trying to do is make let me do that the right way now. Okay, there we go. And now I gotta put this over here, put this one there, and now this one, this one, this one. All right, so if I put it here now, then this will be a diagonal wing. So you've gotta have 4 in a row, starting from anywhere, ending anywhere, as long as it's just 4 in a row, horizontally, vertically, or diagonally. Those are the simplest possible rules for any game, and I've coded those rules for you. So you will be given this user interface, and the game rules are already programmed. So you don't need to program the rules of Connect 4. The way this is going to work under the hood is that each of these actions are just going to be an integer associated with the column that you're dropping the piece in from left to right. So this, if this is the default board, it's just a blank board, then taking action 0 would result in this board, okay, where I have placed a piece over here. Ignore the temporary piece that I have moving around down here. So that's action 0. This is action 1, 2, 3, 4, 5, and 6. So those are the actions. And what you will say is I have a game state class, and I'm not going to go into the code here. I'll do the code later this evening so I can have more time for it. But do action X is going to put a piece in column X starting from 0. And so because the board width is 7, then the maximum action by default will be 6. Okay? Over here, you can see in the user interface, the first thing that I'll show is that we have some controls and some sliders. And so there is board width and board height. And as you can probably imagine, changing these changes the size of the board. Okay? So by default, Connect 4, the actual physical game that you play, is 7 by 6. So it's 7 across and 6 high. That makes the game interesting because, for example, one of the interesting properties of having 7 width is that placing the first piece in the middle blocks the other person from being able to make 4 in a row on the bottom, right? So it's just a little interesting property. But in order to make this a little more interesting, there's going to be an in-class competition between all your AIs. And when I do that, once I get up to the semifinals or the finals, I may play some games on a larger board, right? So if you want to be able to win, make sure that you're not hard coding anything for the size of the board, but you're doing that algorithmically so that, okay, if there were 9 actions, this would be able to take 9 actions, right? So don't say, don't hard code any moves or anything like that specific to the size of the board. So that's what these controls do. They just change the width and height of the board. Up here, very importantly, and let me just zoom in here, is the current player of the game. So by default, this is human. And human just means that you can place pieces on the board with the mouse. That's it. So if human is selected, then no AI will be doing any turns, and you will have to make the turn for that player with the mouse itself. So for example, right now, if I have human and human, then I'm taking turns for both players. And you can see whose player it is to move by when I highlight it, the red stone is being moved. So that's what that is. If I select one of the other things, so let's come over here. What we'll see when we look at the code is that there is a player class. And the player class essentially just has a get action or a get move function. And so that will take in a state and it will return the move that you're supposed to do. And so by default, what I've done is there are a few different players here. 2 of them I've completed for you, and then student alpha beta is the one that you'll have to complete. So, for example, let's just say that we have the random player selected for both. What that does is it looks at the board and it says, take a random legal action. So what does a random legal action mean? Why wouldn't all the actions be legal? Well, in Connect 4, the columns can fill up, right? So if the column is full, then that's no longer a legal action. So I'll explain to that in the code how you would say that, but essentially every column is just going to have a height variable, and if the height is greater than the height of the board, then it's no longer legal. But this, excuse me, this player, it's selected now, but nothing is happening because down here I have some more controls. The controls that I want you to focus on right now are do single AI turn, restart game, turn on autoplay, and undo action. So ignore all the other buttons for now. So if I do single AI turn, whichever turn it is, it will take the player object and do that action, whatever its logic is. So if it's random, this is just random, like literally just doing random moves, okay? And okay, so I wasn't watching, it completed a game. Now, let's say, for example, I wanted to run a bunch of random games for some reason. Well, what I could do is turn on autoplay. So what autoplay means is that if the current player to move is a non-human player, it will automatically call the getMove function for that player. So if, for example, I have both random players turned on here and I turn on autoplay, it will just automatically play games as fast as the UI is refreshing. And because this UI is just being drawn at 60 frames per second, then that's what's happening. Okay, so each move should take approximately 1/60th of a second. So that's what's happening. That's random. Okay, there's one other player here that I've coded, and that is greedy. So what greedy will do, let me play greedy versus random, I guess. But greedy, okay, yeah. So what greedy does is it just places the stone on the leftmost column that it can, except if it sees that a win is possible on this turn, it will take it. So technically, what the greedy algorithm does is look over every move that's legal, and if one of them will win the game, it will take that action, and if not, it will just take the first action that it saw. So that's just a very simple one-step look ahead type of thing. So yeah, random versus greedy, it's likely that greedy wins all the time because it's just placing in the leftmost square. And if make sure you, yeah, I know, but please put up your hand if you have a comment. It is possible, it's always possible for random to win, right? But you're not going to go into a board game competition just hoping that your random algorithm wins, right? And one of the things we will do when we're grading is play your alpha beta against random. Just like a couple of games really quickly. And if it doesn't beat random, then something is really wrong. Yes, there is a 1 in a trillion chance that random played just like Gary Kasparov or whoever your favorite board game player is, but it's very, very, very unlikely. So you can use those for testing though. That's what they're there for. And then the last one is student alpha beta. And the student alpha beta comes with 2 parameters here. Those parameters are time in milliseconds. So by default, I've set it up to be 1 second. And then max depth, and I've set this up to be 1 by default. So what's going to happen is in your code, your algorithm is going to run until the first one of these is triggered. So for example, if I have a max depth of 2 and a time limit of 1, it's very likely that your algorithm, unless you've done something terrible, is going to be able to make it to depth 2 in less than a second. This should take just a few milliseconds, really. So here, what will probably happen is your algorithm will go to depth 2 and then stop. But if I had this set to depth 20 or depth 30, it's very unlikely that your algorithm is going to be able to search to depth 30. So what will trigger here is the time limit. So every time your alpha beta function is going to be called, it's going to check if one of these 2 things is true. Either the time limit has passed the time limit or the depth limit is past the depth limit. And if one of those is true, then it's going to halt execution. Now, what's really important here is that I can set either of these to 0. So if I set the maximum depth to 0, what that means is that in your code, you are going to ignore the depth limit. So a depth limit of 0 means that there is no depth limit, and this will always go to 1 second, right? Similarly, if I set the time limit to 0 and the depth limit to 10, then you are ignoring the time limit because obviously you've taken longer than 0 milliseconds. And so in this case, your search, no matter how long it takes, should go to depth 10. Okay? So hopefully that's pretty obvious. You can assume that I will never set these both to 0 because that would mean that there's no time limit and no depth limit, and so this would try to search the entire game tree, and that's not going to happen in our lifetimes, or maybe the lifetime of the universe. I don't know how long it will take, but certainly a lot longer than the assignment is due. So just assume that I'm never going to set them both to 0. However, in the class competition, the settings I will be using is 1 second and no depth limit. So you will have 1 second per action and no depth limit. So make sure that at least this setting works properly. Because if it doesn't, and we run the competition, basically at any point in the competition, I'll have one algorithm against another algorithm, 1,000 milliseconds versus 1,000 milliseconds, and I'll have the console open. And if anyone's algorithm spits out an error, they're just disqualified from the tournament. So the first error, you're gone. So just make sure that your algorithm works. Now, it's very unlikely that you have an error that you wouldn't have caught yourself. Typically, the only reason that you wouldn't have caught the error is because I made the board bigger and you didn't test that. So make sure you test that as well. So yeah, you can play your algorithm against itself just by coming here and turning on autoplay, and then it'll be 1 second, 1 second, 1 second, 1 second. And I have a very dumb AI set up by default. So this AI that I have set up, the solution code, so in this assignment, you're not getting any obfuscated solution code because it would be ridiculous to think that you would, no, how do I phrase this? It's not like assignment 1 and 2 when you saw how the search should work. It would just be doing a move, right? And you don't have to do that exact same move that's because your heuristic function will be different. So me creating a really powerful AI to give you, yeah, it might be fun to play against, but it's kind of useless for your actual assignment, so I didn't give you one. But I did code one here just for the demo, and if I turn on the autoplay, you can kind of see, okay, it's actually kind of dumb. It's taking 1 second per turn, and right now, it has no heuristic evaluation other than detecting wins and losses. So what you should see now, okay, so red properly did stop the loss, but that's all it's doing. It's trying to stop immediate wins or losses. Let's just go until this finishes. Okay, so eventually player 2 won in that case. But it was really dumb. Why was it really dumb? It's because the evaluation function that I'm using by default in what I give you, it just says, if you win the game, it's 10,000. If you lose the game, it's minus 10,000. And anything else is 0. So I have not implemented a good heuristic function for this. And it will be up to you to come up with that heuristic function. When I record that video later tonight, I'll actually illustrate a few examples of what I think good heuristic functions are. Like I'll give a diagram or something, but I'm not going to actually give you the code for that. So whether or not you win or lose will be dependent on that heuristic function, more than likely. But that's how it should work. You should see 1 second, 1 second, 1 second, and if it's not, then check for errors over in the debug menu. Okay, let's go on to the next thing. So that's the players. I think that's pretty obvious what that does now. So down here, oh yeah, there's things like undo action. So let's say, for example, you wanted to go back a few steps. You can undo actions in the user interface. That's easy. The restart game button as well. I'm going to show, before I talk about these buttons, I want to show what these buttons over here are. So alpha beta is a notoriously difficult algorithm to debug mentally because by nature it's a recursive algorithm. And recursive algorithms are kind of difficult to get into your head the first time you do them. So what I recommend for this algorithm, and I'll say this more in the coding section, is implement minimax without alpha beta pruning until you get everything working. Until it's making good decisions, you know, it's actually kind of difficult to beat it, you're passing the tests. Leave alpha beta pruning out of it until the very end, and then put alpha beta pruning in. So you're going to put minimax in, and then you'll be able to test these buttons. So because alpha beta is very difficult to debug, I've put in a few testing scenarios that set up the board in a specific way to test if your algorithm is working or not. So there's depth 1 win, depth 2 block, depth 3 win, and depth 4 block. So what I'll do is, you can just refresh the page, then I'll hit depth 1 win. And it sets up the board like this, and then there's an explanation down here. So when you hit depth 1 win, it says, yellow should win the game immediately by placing a piece on top of the yellow stack at column 1. So up here, it has set the maximum depth of the search to 1. And the maximum depth of the search to 1 means that all we're doing in minimax is just the max part. We're not going max min. It's just max, and then depth 1 is done, and we stop. Okay? So what this means is if you're only looking 1 move ahead, and you are yellow to play here, then what are you going to do? You should take that win, right? So if I click the depth 1 win button, and then I click do single AI turn, your AI should put the piece there. That is passing that test. It shouldn't put it anywhere else. The next one, depth 2 block. So with a search depth greater than or equal to 2, but I have set it to exactly 2, with yellow should block red from winning the game on the next turn by placing its piece on column 5. A depth 1 search will not necessarily place the piece here, since depth 1 only checks for immediate wins. Depth 2 checks opponent replies to your moves. So what does that mean? Well, here we can see, so it's yellow is the player that should move next, right? So as you know, okay, well, if I don't block this piece right here, then yellow is going to move. By the way, you can tell whose turn it is because the last action is highlighted in light blue. So because red is highlighted in light blue, that means it's yellow's turn to move. So if I click this button my algorithm should correctly block that. Why? Because not only did it see, can I win right now, but it looked one depth deeper and saw, okay, for anything I can do, if I don't do that exact thing, on the next turn, my opponent will win the game, right? So let me load that up again, which is a depth 2 block, but I'm going to change my algorithm to only look for depth 1, right? If it only looks for depth 1, it just places it on the left. Why? Because it did not immediately win or lose for any single action. And if it didn't immediately win or lose, then it just places it over on the left. And that's fine. You may think that that's really stupid, right? But there's 2 ways to make your minimax algorithm stronger. One is with a stronger heuristic function. And yes, if I had a stronger heuristic function, even with a depth 1 search, it may have blocked that thing. But the other way to make your search stronger is to just let it search deeper, right? So no matter how dumb my heuristic function is, if I'm searching the depth 10, it's actually going to play pretty decently, right? So just keep in mind that there are 2 separate things here. And if you do have a depth set to 1, and it doesn't block your opponent from winning, that's why. Because it didn't look 2 moves into the future when your opponent will win. It only looked 1 move into the future. Okay, so just again, with max depth of 2, if you click do single AI turn, your AI should place the piece there because it's the only way to survive and keep going. Next is depth 3. So here's the situation for depth 3, and I'll explain it before I read this. So it is yellow's turn to move, right? So if yellow is smart, they will place a piece either right here or right here. That will give them 3 in a row on the bottom. And if you have 3 in a row on the bottom with both the sides open, then red can't stop you from winning anymore. Why? Because if they place it on the right, you can make 4 in a row on the left. And if they place it on the left, you can make 4 in a row on the right. So let me just change this to human. And this is what I'm saying. What is red going to do now? They can't win the game anymore, right? So what they had to do was stop yellow from placing 3 in a row. So let's go back to depth 3 win. Oh no, sorry. You're yellow, so you're trying to win. My apologies. I was explaining the depth 4 one for depth 3. So let me do that again. As yellow, you're trying to make the move for yellow. So your AI should recognize that if I place it here or there, then I can't lose the game at all. Okay, so that's the slightly simpler situation. You can see how complex it is even with me who's done this before. So if I click do single AI turn, then yellow should correctly place the piece either right here or over here, because now red can't win the game, right? So this is how we see now, okay, this is how strong it makes you when you can see 3 moves into the future. And then the last one, which is what I've already explained, is that now it's red's turn to move, or is it yellow's turn to move? Oh, so it's just flipped. So yellow should realize that if I let red connect 3 in a row on the bottom, then it can't possibly lose in the future. So here's what it says. Yellow should recognize that in 4 moves, it will lose the game if it does not immediately place a piece to either side of red's pieces on the bottom row. If both ends are left open, red can place a piece in column 2 and then win the game on its next move. A shallower search than 4 will not be able to see this conclusion. Now, that doesn't mean that a shallower search than depth 4 couldn't put a piece there, but it couldn't draw the same logical conclusion of I do this, you do this, I do this, you do this. Because this does require looking 4 moves into the future, right? So here, if I click depth 4 and I click do single AI turn, then what yellow is going to do is block red from making those 3 in a row on the bottom. Okay, so that's what those test buttons do. And the first couple of times I did this course, I didn't have those buttons, and students would save a game state object and then load it somehow, and it was annoying, so I just put that in there for you. So those are the 4 tests that's the first thing you have to do to pass the assignment, is pass those 4 tests. And if for some reason it doesn't work, then something is wrong with your algorithm, 100%. All right, so now let's look at the other buttons. There is an eval button and a Zobrist button. So the Zobrist button is really easy. So that's for the 6980 students. So there will be a function in the GameState class called Zobrist or getZobrist or whatever it's called. And what you have to do is you have to calculate the Zobrist hash function for that and then return it. And that's all, right? So that thing of you were going to have to create random tables or random values associated with each color piece being at each place on the board, and then calculate the Zobrist function. And the way that we'll test that is, for example, the Zobrist hash of an empty board should just be 0, right? So we're going to do that. We're going to make a move, and then whatever, let's say we do this, right? And then we'll click the Zobrist button, and some big long integer will come up, and that's going to be the Zobrist hash function for that board. Then we're going to create that state again, but through a different sequence of actions. And even though the sequence of actions may be different, it should have the same Zobrist value. Okay, so that's what the grad students have to do extra in addition to choosing an optimization. And the last button here is, for your own sanity, it's called the eval button. So I'm going to click the eval button, and what you'll see is, up on top now, you see a bunch of zeros. What do those zeros mean? Well, let me set up something interesting. Okay, so what the... Sorry, microphone came off. What the eval button does is that it toggles whether or not it's displaying these numbers. So that all the button is a toggle. So under the hood, and this will be explained more in the code part, but I have created a copy of your student class that contains your evaluation function. And for every time this is drawn, what it does is it takes the current state of the game, it makes a copy of it, and then it applies each legal action to that copy, and then runs your evaluation function. And then it draws those evaluations to the board like this. So because my evaluation function is really dumb, it's just 10,000 for a win, negative 10,000 for a loss, 0 otherwise, what this is currently saying is that if I were to take this action, this would be the value of that state if I take that action. So this is purely for your debugging purposes, right? Because when you're testing your evaluation function, you might want to know, what would my evaluation say if I were to take that move, right? So right now you can see that my evaluation function for whether or not I'm winning the game is currently working. How can I tell that it's working? Because the only action that has a non-zero value is the one in which if I did place it there, I would be winning and my value would be 10,000. Okay? So that's just, you could also have something in your code where it prints it out to the console or anything like that. But I just thought this was a nice way of having that there so you can test. Like, for example, if I were to take this move now, and now it's red's turn to move, so now red thinks this action would have a value of 10,000. Why? Because the resulting state of me taking that action is going to be a state in which I have 10,000. Now, if you do have, keep in mind that this is only a one move evaluation, right? So for example, down here in depth 1 win, it shows a value of 10,000 for making that move. But in depth 2 block, it does not show negative 10,000 for every action but this one. Why? Because it's just a one-step evaluation. If I had changed that to a 2-depth evaluation, then all of these would have a value of negative 10,000, this would have a value of 0, and this would have a value of negative 10,000, right? Because it would say every single move that I could possibly do will end up in losing the game, except for when I block that player. So just keep in mind that in this case, you would kind of expect this to say negative 10,000, but it doesn't because that is 2 moves in the future. It's not the very next move, okay? Just keep in mind that if your evaluations, like let's say instead of 10,000, you want your win value to be 1 million, it's probably going to be too wide for that display without changing the user interface. So just keep that in mind if you have some really, really large number. Probably keep them to some reasonable amount. And I think that's actually everything for the user interface. The rest of it is just me explaining the code. So let's step over to the assignment. So of course we have the assignment mark files. We have some UI files, etc., that we don't need to click. I'll go through the marks at the end, but what I will do first is go over this GameState class. So let me zoom in on this a little bit. So the GameState class contains those 4 variables that I talked about in the lecture: player 1, player 2, player none, and player draw. And so player 1 is a 0, player 2 is a 1. So if you ever need to get the other player, you can add 1 mod 2 to go from 0 to 1 or from 1 to 2. Okay. Player none just means that there is no player at that state. So we'll have functions in the game state like get piece or get xy, right? And if there's no piece there, you will see a 2 or player none. And player draw, that's another situation. So the winner function is going to return one of these. Either player 1 if player 1 is currently connecting 4. Similarly, player 2 is connecting 4. If the game is not over, it will return player none. And if the game, if the board is full, but there's no connect 4, then that's a draw, and so that's what it will return there. So those are the 4 variables that we'll be using to hold the pieces. So by default, when the game starts, you might think, oh, the array, the 2D array that I'm using to store the board is empty. Well, there's no such thing as an empty array. Arrays have to have values, right? So what I do in the user interface here is that if it's player 1, I draw a yellow circle. If it's player 2, I draw a red circle. And if it's player none, then I draw a white circle. So that's how it looks empty, but it's actually a white circle being drawn there. So the constructor for the game state just takes in a width and a height, and all this is given to you. So it sets the width and the height, that's obvious. The first data structure that we use is called this.pieces. And what it does is it takes, it constructs an array of length width and puts 0 into all of them. And what pieces n represents is the number of pieces in column n. So if I go back over here, let's say I've done this, then pieces 0 would be 0, pieces 1 would be 0, pieces 2 would be 3, because there are 3 pieces in this column. Pieces 3 would be 0, 1, 2, and 0. So that data structure is not strictly required, right? I could technically look over all of the columns and figure out that information, but it's nice. It's just trading a bit of memory because the UI has to do things like know where to put this piece when I click it, right? And that's going at the column number equal to the number of pieces in the column. So that's just a little bookkeeping data structure, but you are free to use that in your heuristic function. Then there is the total pieces on the board right now. That's self-explanatory. This single line of code initializes a 2D array of player none of the given width and height. So this is just a simple, not simple, but it's a one-liner in JavaScript that lets me do that just to save a little bit of space. This .player is the player whose turn it is to currently move. And so at the beginning of the game, it is player 1's turn to move, and so this .player is equal to player 1. And the only different variable that can ever have is that whenever player 1 takes their turn, that gets changed to player 2, and whenever player 2 takes their turn, it gets changed back to player 1. So it's either going to be player 1 or player 2, which is a 0 or a 1. This is a little bookkeeping data structure for me, and this is used to calculate the different directions that a connect 4 can happen. So if you're looking at every piece of the board, it can either happen going to the right, going down, going diagonally down, or going diagonally up. So that's what this represents. You can just ignore this. I've actually coded this up so it can play connect n. It doesn't have to play connect 4, but we'll only be using connect 4, so that's just what that is. It's how many in a row you have to get to win. And then this .win info, you can kind of ignore this. This is used by the UI to draw the winner when there is a winner. So just ignore that variable. This .get xy, that will return the piece at the given xy position. That's pretty intuitive, but just keep in mind that that is represented from the bottom up, right? So x equal to 2, y equal to 0 would be player 1 in this case, because Connect 4 is played from the bottom up, so that's how I coded it. This function returns whether or not a given xy position on the board is valid. So this is like if you're iterating pieces over pieces on the board, you can use this function if you want to, just like the is out of bounds function from assignment 1 and 2. This is the function that does an action. So how do we do an action? Well, actions in this assignment are represented by integers, and the integer represents the column index that we want to place the piece into. So this over here, placing this, that is taking action 0. Right here, that would be taking action 3. And so, okay, what would happen here inside the game engine if I said do action 3, right? So that would be here. Well, a couple of things have to happen. First, I have to place the piece, right? Second, I have to switch the player to the next player. So let's see how the game does that. So it says this dot board action. So action is the index of the column, right? So X is the column here. And then it finds the place that the piece should be put by calling this dot pieces action, right? So over here, this dot pieces, that would have stored 1. So that index 1 is where this piece will be put. And this says then plus plus. So plus plus is a post increment operator. So that means that after this line of code has been called, that variable will be incremented. So I've done all that in one line. And that place on the board just gets the value of the player. So if it was player 1, you'll see a 0 there. If it was player 2, you'll see a 1. Then I switch the player to the other player. So I just switch 0 to 1 or 1 to 0 with that line of code. And then the last thing I have to do is add a piece to the total pieces on the board. Okay? So those are the 4 things I guess that it does. It puts the piece in the place on the board, increments the number of pieces in the column, switches the player to the other player, and increments the total number of pieces on the board. The undo action function is the opposite, essentially. Instead of putting a place on the board and increasing stuff, it takes a piece off the board by setting it to player none. So here, it's kind of the opposite, right? So this is a pre-decrement, meaning it will decrement the number of pieces in the column before it uses it as the index, sets it to player none, then sets the player to the other player, and then decrements the total number of pieces. And I just have this console log warning that if you try and undo an action that has no pieces in the column, then that's an illegal action, right? So it doesn't technically record the last move that you did. It actually undoes like the top piece of a given column. So just keep in mind that undo action does take in an action as a parameter here. Let's keep going. Is legal action. So is legal action is a function that's done for you. And what it does is 2 things. It checks to see if the action that you're passing in is between 0 and width minus 1. And it also checks to see if there is a space left in this column, because it's not a legal action to place it on 0, 1, 2, 3, 4, 5, right? Because you can't place an action there anymore. So that's the is legal action function. Then I have another function for you called get legal actions, which literally just sets up a new blank array, iterates through all the possible actions, which are all the different columns in the board, checks to see if each of those is a legal action, and if it is, it adds it to the array and then returns it. So in your code, where you go to check all the next actions, you can just call this dot or the GameState.getLegalActions, and that'll already be done for you. These functions down here, you can look at them if you want. They may be helpful in using them as example code for your heuristic function, because the heuristic functions here have to do with any good heuristic function for Connect 4 is going to be checking like vertical lines, horizontal, diagonal, all kinds of stuff. So this just essentially, this function checks if at x, y on the board in a given direction are this many of the same color connected. That's it. Really simple. And then this one down here, the winner function, for each possible place on the board, it calls this function to check to see if there's a win there for either player. Okay, so that's all that does. I have also created a function for you called copy. And what this does, this is a deep copy of the state. So who here has learned the difference between a shallow copy and a deep copy? Oh, wow. Okay. So I guess the object-oriented folks are failing you in their course. So there's two notions of copying an object. One is called a shallow copy and one is called a deep copy. With a shallow copy, if I just made a shallow copy of this state contains a number of arrays, okay? And by default, if I was to say this new array is equal to that old array, it will essentially just be a pointer to that original array. So if you modified the new state's arrays, and those arrays are pointing to the original arrays, then you would actually be modifying not only the state you copied to, but the state that you copied from. That's why it's called a shallow copy, okay? A deep copy literally creates new arrays and populates them with the same data from the old state. That way you can modify the deep copy and it won't affect the old copy. So this is a deep copy, and if you've used Java before, Java has a function built into it called clone that will do a deep copy for you. And as far as I know, JavaScript doesn't have that, at least not in a way that I wanted. So this over here, this is just a deep copy, where it sets the player, sets the total pieces, and then literally copies all the data to the new state. So that's the game state. It has everything you need to know for Connect 4. You can see how easy the rules are for Connect 4. The hardest part about Connect 4 is just counting 4 in a row, right? Which isn't too difficult. So that's the game state. Let's move on. I don't need to talk about the UI or the index. That's the same as the other ones. It just handles that. The next one I will look at, however, is the player. So the player class, right here I have player random and then player greedy. And what you will be making is player student. So remember that if you want to, you could modify player random or player greedy, and then any modifications you've done to it will be in the player when you select it from the drop-down menu, right? So for example, one thing you can do if you want is like, okay, I don't really care about player greedy anymore. So I'm going to take an old version of my player and I'll copy it in there and call it player greedy, and then that version of the player will be there. But that may actually not work out because of the UI, so just be careful when you do that. But these are here for you essentially as sample code, okay? And just realize that any modifications that you make to Player.js are not being submitted, right? So if your code somehow relies on something that happens in this file, that's not good. The only file you're submitting is your player class file. But anyway, let's see how the player random works. Well, any player class has to have two functions implemented for it to work with the UI. The first one is a constructor, and the constructor here, it doesn't really need anything, right? Your constructor will have stuff because you're doing like alpha, beta, you need all these variables, etc., but the random player doesn't need any extra variables. The other more important function is the getAction function. So what the UI does is it says, hey, whatever player you have selected, I'm going to call its getAction function on the current state. Right? So it'll deep copy the state and pass it in for you. So if whatever state I have passed in, let's look at what the random player does. First, it gets an array of actions that are legal at that state. So I just say let actions equals state.getLegalActions. Couldn't be easier, right? That's how you get your legal actions. Then I want to select not a random number on the board, but this is an array of legal actions. So what that means is I could have a situation like this, right? So here, 0 is legal, 1 is legal, 2 is not legal, 3 and 4 are legal, 5 is not legal, 6 is legal. So what you would get from get legal actions is an array containing 0, 1, 3, 4, 6. Okay, so that's what that will return. So over here, what I want to do is create a random index of that array. So if there are 5 things in the array, I want a random number between 0 and 4, right? Because that's picking the index. And so that is the index into the array. And here's how you do that. Math.random gives you a number between 0 and 1. Multiply that by the length of the array, and then floor it to get an integer. Okay? Then what I do is, now remember, that's not the random action. That's the random index into the legal actions array. And so I have to then go through actions and look at that index, and then that's the random action. Okay, so that's pretty intuitive. I think you can all manage that. And then player greedy down here, what this will do is that one step look ahead, remember? So player greedy is going to have two functions. It's going to have an eval function, and the eval function is very similar to your eval function that you're going to have in your player student, where you have your heuristic function. But this one essentially just calls the winner to the state. It says, hey, who's the state winner? If the winner is the player that I'm evaluating with respect to, right? So this is important to recognize. Eval takes a player as a parameter. Because if I look at a state where yellow is winning, if I pass in yellow, then I want 10,000. If I pass in red, I want negative 10,000, right? So it's very important who you're evaluating the state with respect to. So if the winner is the player, return 10,000. Now, you guys don't have to use 10,000. I've just put that in here. If you have some other variable that you want to use, by all means, that's fine. Otherwise, if it was the other player, return negative 10,000. If it was a draw, then return 0. And right now, this evaluation function just says, if the game is still ongoing and nobody has won, then it's just a 0, okay? So I'll get to that part of your code once I get to the player student function. But this is the evaluation for the greedy player. Then what it does is very similar, like you're going to essentially use this as sample code for your iterating through actions. So first what we do again is I get the legal actions at the state. Then I set the player whose turn it is to move. So if that's yellow, it's yellow. If it's red, it's red. Then since I'm going to be taking the maximum of a bunch of evaluations, I'm going to have two variables. One is to record the maximum value that I saw, and the other is to record the maximum action that created that maximum value. Next, I'm going to loop over all the different legal actions in the array. For each action that's legal, I'm going to copy the state. I'm going to issue actions A to the child state, and now I've got the state after it's been issued, right? So this is the state after which I've done this action. Then I evaluate that state with respect to the player to move, right? Now look at this. This is important because here, if I had said child.player, then I would actually be passing in the other player, the opposite player who I want to evaluate it for. Okay, so it's important that we get the player right. Then, if it's a new maximum, set the new maximum and record the action that did it. And that's it. And then you return the max action. So that's just your sample code to step through all the actions at a state, create the child states, clone them properly, issue the actions, and get the evaluation. So that's the sample code that you can use for yours. So those are the two players. And you can see with this architecture, it's like really easy to create a bunch of players. You could create a player who always puts it on the left, who always puts it on the right, always puts it in the middle, and you can stick it in there. And well, yes, you would have to modify the UI if you actually want to make it selectable. But you can see now how kind of cool and modular this all becomes, right? Oh, I can just create a new player class and stick it in, and now that player is playing the game. It's really cool to be able to do that. Let's see, what else do we have? Well, I'm not clicking on that. So only player student is remaining. And this is going to be the bulk of the explanation. Okay, so up at the top here, I'll read this first. So this says, if you did any optimizations beyond what is required for the assignment, please list them here and give any references used for their implementation. You may use websites such as chessprogramming.com, but you may not use ChatGPT or any other automatic code generation tools. So I suggest once you have gotten all your alpha beta code working, it passes all the tests, and it's probably, doing pretty well when you play against it, then what I would do is if you actually want to win the in-class competition for all that crazy street cred you'll get, you can go onto these other websites, look at the lecture that I gave for for the optimizations, the search optimizations. Choose a couple of those if you want to and implement them, but list them here with references. So you could say, hey, I implemented this type of improvement, and here's where I got it. I got it from your slides, or I got it from this URL. But what I don't want is you to just paste your code into ChatGPT and say, give me an optimization, right? I don't want that, because that's not learning. That's just, you'll have plenty of time for the rest of your life to use ChatGPT. Try and learn while you're in this course. Okay, here we have the constructor for player student. And the first thing we have is this .config. And just like all the other assignments, some of this stuff is in that config, right? So your player will get this .config containing two variables, one of which is time limit and one of which is max depth. So that's the config part. So if I go back, this .config.timeLimit is going to be the maximum time limit for the search. 0 means there is no time limit. So you may have to have like an extra if statement in there that says if it's 0, don't check for the time limit, right? Something like that. Similarly, this .config.maxDepth is the maximum search depth for iterative deepening alpha beta. So when you're going through iterative deepening alpha beta, you'll be looping from 1 up until this .config.maxDepth. And again, you might have to have a little extra if statement there that says, if there's 0, then I am no longer cutting off at any max depth. I will only be using the time limit. And I think I say this later, but just to mention again, that for the class testing, for the TA and for the competition, you can always assume that one of those will be non-zero. So don't worry about the case where they're both 0. We will not be letting your program try and like solve the whole search tree. I realize that won't happen. So one of them will always be non-zero. This .search start time will record the construction time of your algorithm, okay? So what does that mean? The way that computer clocks work when you want to time some code is there's not like a process running in the background ticking like an actual clock. What happens is you're going to make a system call that says, what is the current time in milliseconds? And so what you'll do is you'll record that time. So let's say, for example, the current time in milliseconds is 1 million milliseconds, whatever that means. Then later on, you'll be able to say, what time is it now? Maybe it's 1,010,000 milliseconds. You'll take what time it is now, subtract when your search actually started, and you'll see, oh, my search has been running for 10 milliseconds. And so that's how you're going to be doing the timing part of your code. And I have sample code for that in a bit. Next, we have 4 variables that are related to iterative deepening and alpha beta. And those variables are the same variables from right here. Okay, so go back to that part of that lecture and watch where I talked about those variables. But essentially, this is going to be best action. That is the best action overall found by iterative deepening alpha beta from the last fully completed depth. This is the current best action that your current depth of alpha beta is recording its action to. Current max depth is the current maximum depth that iterative deepening is going to. So for example, the current max depth is going to start at 1. Then when it's finished, current max depth is going to start go to 2, to 3, to 4, etc. This .max player, that is the current person who is the root node of the search tree that you're trying to maximize for. So whenever you start a new search, just say, oh, this .max player equals state.player. Because you might need to know who you're maximizing for at some point during the search tree, and you've forgotten who you're maximizing for, right? So just record that there. This is just some debug output that prints out to the console, so you can ignore that. And then for the 6980 people, you will probably have to create some arrays of random values. So if we go back to the Zobrist lecture, you'll see that for each piece on the board, so there are 42 different places on the board, what you will need to do is store 3 different values. One representing there is a yellow piece on the board there, one representing there is a red piece on the board there, and one representing that there is no piece on the board there. And then to calculate the Zobrist function, you're going to iterate over all the pieces on the board, and do the XOR of all of those pieces, starting from a 0, which is the empty board. Okay, so that's the Zobrist part, but you will need somewhere to store those things, and so I recommend creating them there in the constructor, because what will happen is the constructor gets called once whenever you select the algorithm, but if you could imagine creating the Zobrist values in the get Zobrist hash function, then every time you call the hash function, you'll have different random values, right? And that's not what you want. You want a set table of random values once, and then every time you call the Zobrist function, you're using those same random values. Next, we have that get action function. So if we went back over to the players, every player has to have a get action function, which takes in the state. And so this is that interface for the player student, but all it does is calls this.id alpha beta, right? So that's our iterative deepening alpha beta. So it just calls that right away and returns the value. So let's look down at iterative deepening alpha beta. Here's the function. So I'll just read this out. This function should implement IDAB. It should call the separate alpha beta function which implements the minimax search with alpha beta pruning. This function should use the this.config configuration options for the following. I already described those. You can assume that one of time limit or max depth will always be greater than 0. Please note that both of these limits should be used, and whichever one happens first should be the stopping condition, right? So if you've got a 1 second timeout and a max depth of 4, you're checking for both of those, and whichever one returns true first, that's your cutoff condition. So be sure to return the best action from the last completed alpha beta search. So here, this is the ID alpha beta function, and this performance.now, that is how you record the current time in JavaScript. So when I call the search, I'm setting my search start time, and then down in my alpha beta function, which I'll just show briefly, I'm going to calculate the time elapsed by saying what time is it now and subtract the search start time. So that's how you're going to calculate the time limit. The iterative deepening alpha beta code, what I highly recommend is going over here, going to this function, literally selecting all this, copy, go back here, paste, and then just turn it into JavaScript. Don't copy and paste from Wikipedia, from ChatGPT, whatever. I've literally given you the pseudocode solution. It is how I want you to implement it, and anything different will be just weird, right? Now, if you've gone off and you've found some optimization on that, by all means, but make sure you cite it, right? So just keep in mind that I've basically given you the solution to this assignment. You just have to turn it into JavaScript. Next function. It's the actual alpha beta function where you are writing this code. So same thing. There you go. The only thing here is you might have to write the isTerminal function, right? And the isTerminal function is just, hey, is that the end of the game? Right? So it says if it's terminal or this is greater than the current max depth, return eval. Otherwise, if it's a time limit, throw an exception. Okay? Now, throw timeout exception. That may or may not work out of the box. You may just have to throw a generic exception. I'm not sure what the exact syntax will be, but you're going to throw an exception. And then up here in your iterative deepening alpha beta, this try catch is going to catch that exception. And we talked about that already, so I won't waste any more time on that. So the alpha beta function, let's just read this. This function should implement minimax with alpha beta pruning. It is recommended to first get vanilla minimax search working properly before implementing the alpha beta pruning enhancement. Please be aware that this function does not return an action. It returns a state value. Actions must be set to a class member variable rather than being returned. It is important that you copy states before generating children, otherwise you'll be modifying the reference states on different levels of recursion. Once you have it working with copy, then go back, and if you want to make it faster, implement the undo action optimization that we talked about later. So I highly recommend when you first start this, ignore the alpha and beta variables, just implement minimax, do it with copying states, get that to work, get your tests to pass. copy and paste that file somewhere as working. Then go back and put in the alpha beta variables. Trust me, it will dramatically, like, it'll be faster to do this, in my opinion, than to do the other thing. And it will help you with your debugging as well. So down here, I just say check Players.js for example code on how to iterate through your actions. And what does that mean? It means down here in the alpha beta code, where we say foresee in children, that's the loop that we did inside the greedy player, where I say get the state, look at the legal actions, blah, blah, blah. That is that there. Okay. Oh, and also, you know, you've got some v primes, etc. So this is still pseudocode. You're going to have to say let value equal whatever, if value greater than max value, etc. So it's not like completely done. You just have to change it into JavaScript. So I recommend doing this first and then doing the alpha beta version. Okay, so that's alpha beta. Here is where you might spend most of your time if you're concerned with winning the in-class competition. The alpha beta function, like I said, that's just basically given for you. This function is the eval function. Where am I? Sorry, I don't mean to make you seasick here with this. Okay, this function should compute a heuristic evaluation of a given state for a given player. It should return a large positive value for a good state for the player and a large negative value for a bad state for the player. Assign the maximum possible values to winning and losing states, and be sure to assign values in between for states of a game in progress. This is one of the most important factors for your program performing well in the class competition. Poor heuristic functions cannot always be saved by good search. Note, be sure to pass the player variable into this function. JavaScript will not throw any error if you miss that variable, which will lead to strange behavior. Most of the time, you will only be calling this with the player equal to this.maxPlayer. And so, what I've done for you is I get the winner, I do the 3 end of game examples where if the max player wins, it's a big positive value. If the other player wins, it's a negative value. If it's a draw, it's 0. And this is where you have to put in your good evaluation function. Now, this is always a little bit contentious because basically what I want you to do is put a little bit of thought into this and create something that's not absolutely trivial. Okay? But if you've never played Connect 4, it might be difficult to come up with a good heuristic function for Connect 4. So let's just take that idea and have a look for a little bit. All right. Intuitively, is placing my first piece on the left or on the right a good move? No. Okay, you're shaking your head. Why is that not a good move?
Not enough possible connections after that. So
There you go. Okay, so that's a good verbiage, is that the answer was there are not enough connections. If I place myself into a corner, then I've cut off half the ways that I could get a Connect 4 with this piece, right? Not only that, but I haven't stopped my opponent from getting any Connect 4s either, right? So look, if I had placed my first piece in the middle, now I can make a Connect 4 over here, up diagonally, back diagonally, vertically, and I've also stopped my opponent from getting a Connect 4 on the bottom row on this diagonal. Like, it's just such an insanely better move. So what I highly recommend for your heuristic evaluation function is some function based on the number of ways that I could still possibly get a Connect 4. You could maybe, okay, if I have 500 ways that I could still get a Connect 4, and my opponent only has 200 ways that I could get a Connect 4, maybe that's an evaluation of 500 minus 200, which is 300. And a better possible ways that I Connect 4, or that I could get a Connect 4, might be a good heuristic evaluation function. Similarly, you could look at things like, how many 2 in a rows do I have? How many 3 in a rows do I have that might still get a Connect 4? So it's all about possibilities. How many possibilities do I still have open after I've made this piece? And then if you apply that to the opponent by passing in the other player into this function and subtract them, then you would have a single number representing some sort of goodness about that state. right? And basically, if your player is going first and they're not placing it in the middle, no, you don't want to hard code that. You never want to hard code absolutely anything in this assignment. Even if it's very tempting in your heuristic evaluation function to have a look and say, if my opponent has 3 in a row and they can place it there, then hard code it to place it there. It makes sense, intuitive sense. But it really doesn't, because that will screw up your heuristic evaluation function, and your search should cover that, right? Your search should see that when I make a move, I will block him from winning, right? So don't be tempted by the dark side of hard coding, put it in the middle. Your function should figure out that the middle is good for some reason. So you don't hard code stuff like that. You will lose marks for hard coding in your evaluation. But beyond that, yes, you can go out and see what other people have done if you want to, like do a deep dive into Connect 4 heuristic evaluations. But please don't copy their code, just copy their idea. I still want you to do that. And if you do take an idea from somewhere else, again, just cite it. I'm allowing you to go out and do it, just not ChatGPT, right? That is not, your chat output from ChatGPT is not a valid citation for this course. Okay, so that's what you have to do in here. And basically, if we think it was enough work, like if you did that thing of the number of ways that I could still get a Connect 4, that will be sufficient to get full marks on your heuristic function. But not something like, if it's in the middle, it's 10 and I'm done, right? You've got to have a paragraph or 2 of code in there to do anything interesting. At the bottom here, this is where you are calculating your Zobrist hash function as the 6980 students. So you've got your tables of values that you made of the constructor, and here is where you would go over, iterate over every spot on the board, and then return the XOR of all those pieces. I am not requiring that for this assignment, you implement an incremental version of Zobrist. The reason for that is because in order to do that really well, it kind of has to be done on the GameState side. But if, for example, you wanted to implement a transposition table, which would blow everyone else out of the water. Like, transposition table, even if you have a bad evaluation function, it just lets you search twice as deep, right? So if someone is using the Zobrist hash function as an index for a transposition table and gets that working, that's like, and nobody else does that, they'll probably just win because it's so good. And I'm saying all of that because if you do want to do that, then you may want to consider trying to implement the incremental version of the Zobrist hash function, because it's a lot faster than the full Zobrist hash function being calculated every time. Like if you have 30 pieces on the board, then this is iterating, it's a bunch of checks, you're always iterating over the whole board, it's a bunch of XOR statements. But if you can just say, whenever I put a piece on, I'm XORing a piece in, like that's really fast. So someone who does the incremental version will probably beat the version who doesn't do that. And what I recommend is there are no guarantees here that any of these optimizations make your AI stronger, right? It's kind of an experimental process. So you know that alpha beta will make it stronger, right? Because alpha beta returns the same result, but faster. But it's very tempting to go in and just say, I did a transposition table. And the number one thing that happens for first-time transposition tables is that you get it wrong and you don't realize it. And you're using data in a weird way that actually makes your program worse than if you hadn't used it. And so be sure to test it. Just throw it in another class file. You can modify the UI if you want to. You can replace the greedy player with your player, hand code the config or whatever you want to do in order to do it. That's fine. Now, I do not recommend. I don't like groups sharing their code between them. But for this assignment, and this assignment only, if while you're developing your AI, you do want to play it against someone else in the class, I'm allowing that. Just go on the honor system and don't steal all their code, right? So if they want to send you their file so you can play it against them just to see like, oh wow, yours is way stronger or whatever, I'm allowing that. But just mention that you did that. Like, hey, I played it against this, and that result made me realize that I should do this. It's cool to see the journey that you went through to get to a really strong agent. I'm more concerned with the story and with you learning than with you giving me the code. I have thousands of versions of Alpha Beta that people have given me over the years. I don't need another one. But I always need another student who learned this stuff and had fun with it. So please do that. Is there anything else here? Oh yeah, the marks. So the 3,200 marks are pretty basic. It's like 5% for code readability, etc. 10% for the heuristic. And so I already mentioned that, like, you know, you got to do sort of enough for the heuristic, but I don't want 70 emails asking me if it's enough, right? If you've written a page of code for your heuristic and it does something interesting, that's fine. You get marks for iterative deepening alpha beta and alpha beta working correctly. But let me quickly go over to the 6981. So I take some of the marks from iterative deepening alpha beta and alpha beta to put into the Zobrist hash function, as well as for 5 marks, so it's not worth a lot, but it is needed. I want you to go to chessprogramming.com, and it has to be listed there, and you have to cite it as one of the bonus things that you're doing for your assignment. So that is the grad version of independent thought and a little bit of research. So any of the things in my slides where I linked to chessprogramming.com, you can do that as your optimization, or you can find something else there. Like, for example, move ordering. If you somehow get values for a move either via transposition table or maybe some other heuristic evaluation, and you want to implement move ordering, and you find that it works, you can put that in there and that will be fine, right? But any of the ones that are actually cited on chessprogramming.com are fine for that. And if you just want to get 95, that's fine too, right? You don't necessarily have to do that.